Inshallah, in today's class, we are going to continue comparison test of infinite series. In the last class, we have done few questions, and if the comparison test, we have done the DLM-bus ratio test questions. If the test fails, we go into comparison test. But sometimes we cannot use comparison test because it is difficult to suppose Vn. So when the test fails from DLM-bus ratio test, and if we cannot able to use the comparison test, we have to use Raabe's test. So first you see what is Raabe's test. Limit n tends to infinity n into un by un plus 1, where un is the nth term of positive terms minus 1. Watch carefully. Greater than 1 means convergent. Greater than 1 means convergent, and less than 1 means divergent. Less than 1 means divergent, and equals to 1 means test fail. Equals to 1 means test fail. So you must by heart this one. Greater than 1 convergent, less than 1 divergent. What is DLM-bus ratio test? In the last class we have seen little change difference here. This we have done like this, un plus 1 by un. Here less than 1 convergent, greater than 1 divergent, equals to 1 test fails. Only the difference is here we have used un plus 1 by un, whereas the here n into reciprocal of this un by un plus 1. Therefore conditions also changes. Greater than 1 convergent, less than 1 divergent, whereas here less than 1 convergent, greater than 1 divergent. One more thing is here, watch carefully. We doesn't require to solve all, just we have to reciprocal this one, you will get this. Let me see one example. Okay, now you see here is a question on the board. We have to see whether the series is convergent or divergent. Let me find the nth term first. This is first, second, third term, three terms, fourth term will be four factors, fifth term will be fifth factors. By see lighter we have to see for the nth term. So you see here what is numerator, 1 3 5 so on. So let me find the nth term of this. What is the formula we are having? A plus n minus 1 into d. A means first term 1 plus n minus 1 into d means difference, 3 minus 1 is 2. So multiply 2 into n, 2n minus 2 plus 1 minus 1. In the same way denominator, what are the denominators we are having? 2 comma 4 comma 6 comma so on. So nth term will be a plus n minus 1 into d. What is here? 2. So multiply 2 into n, 2n, 2 ones are 2 minus 2 plus 2 will get cancelled. Therefore we are having un now. Un can be written as here 1 into 3 into 5 into so on. So the odd numbers we are having 2n minus 1 divided by 2 into 4 into 6 into so on. Its nth term is 2n. So this is un. Now for use this formula we have to use find un plus 1. So what will be un plus 1? In place of, you see here un plus 1 means from here to here you write as it is. This will be 1 into 3 into 5 into so on, 2n minus 1. So we have to know what is the next term. Next term means in this we have to keep in place of n plus 1. The next term of this will be in place of n plus 1. So what will be this one? 2 into n, 2n, 2 ones are 2, 2 minus 1, 1. In the same way the denominator 2 into 4 into 6 into so on, 2n. In the next term in place of n, if you keep n plus 1, multiply 2 into n, 2n plus 2 ones are 2. Now first we have to use DLM-bus ratio test. DLM-bus ratio test. What is its formula? Limit n tends to infinity. Limit n tends to infinity. We have done like this. Un plus 1 by un equals to limit n tends to infinity. Un plus 1 is this one. 1 into 3 into 5 into so on. 2n minus 1 into 2n plus 1 divided by 2 into 4 into 6 into so on, 2n into 2n plus 2. So this is the un plus 1. Now we have to write un. So this is new un. Instead of writing in the denominator, if we write in the numerator, this will become reciprocal. So write numerator into denominator, denominator into numerator. 2 4 6 so on, 2n divided by 1 3 5 so on, 2n minus 1. Now let me cancel the terms. Watch carefully. 1 into 3 into 5 into 2n minus 1. This is 2n minus 1 get cancelled. Up to 2n you will get cancelled. So what is left? Once more I am writing this. limit n tends to infinity, un plus 1 by un is left with a 2n plus 1 by 2n plus 2. You note this, let me use this one afterwards. So now let me take to n common. If you take n common here, limit n tends to infinity. If you take n common, 2 plus 1 by n. Here also if you take n common, it will be 2 plus 2 by n. Now this n will get cancelled. If we substitute infinity, 1 by infinity 0, 2 by infinity 0, 2 by 2. 2 by 2 is nothing but 1. Therefore limit n tends to infinity, un plus 1 by un equals to 1. Just now we've seen the test fails. Now if the test fails, we have to change the method. When we have to change the method, we are having un is, watch carefully, 1 into, this is 1 into 3 into 5, so on, this is so on. So we cannot use comparison test best because we cannot suppose here vn. It's difficult to suppose vn here. So we have to use in Raabe's test. So what is Raabe's test? Raabe's test, let me write now. Raabe's test is little change, limit n tends to infinity, n into, must change the use the reciprocal, un by un plus 1 minus 1. You see here, limit n tends to infinity, n into, we do not need to write again all this, we are just have here, you see here, un plus 1 by un, this term you take un plus 1 by un, but this is the reciprocal, so you make the reciprocal of this. This is un plus 1 by un, whereas this is un by un plus 1. So reciprocal of this will be 2n plus 2 by 2n plus 1. So n into this minus 1 minus 1. So let me take the LCM first. I'm writing here, limit n tends to infinity, n into, you multiply this one, 2 into n, 2n plus 1, minus into plus minus 2n, minus into plus minus 1, divided by 2n plus 1. Now you see here, we can cancel this one, plus 2n minus 2n cancel. So what is left here, 1, 2 minus 1 is 1, 1 into n is n. Limit n tends to infinity, n divided by n divided by, see here, let me take n common here. If you take n common here, left with 2 plus 1 by n, 2 plus 1 by n, this will get cancelled. Now if you substitute infinity, what will happen, this will become 1 by infinity is 0, 0 plus 2 is 2, so 1 by 2 will be the value, therefore less than 1. No, limit n tends to infinity, n into un by un plus 1 minus 1. We got this 1 by 2, 1 by 2 is nothing but less than 0, less than 1. Therefore for less than 1, just now we have written in the top of the board, you see here, we are having here, this is nothing but less than 1, divergent. Therefore what we say by DLM-Bur's, sorry, by, therefore by Raabe's test, by Raabe's test, the series is divergent, the series is divergent, the series is divergent. Now let me start the next question. We have to see whether it is convergent or divergent. Let me first find the nth term. Now watch carefully how to solve. See, these are the odd numbers and the x power is also odd. What is the difference? 1, 3, 5, the next is 7, and the denominator, these are the even numbers. So let me see the odd nth term of 1 comma 3 comma 5. So this one, so this will be tn equals to a plus n minus 1 into d is 2 here. So this will be 2n minus 1. Now you see here, what are the powers of x? If you see the powers of x, 3, 5, 7, you leave this one. We are not including this because it doesn't follow the exact rule. So leave this one. Now see here, what is here, x power 3, x power 5, x power 7. These are the powers of x. So only the difference between this and this is a is different. So here a is 3 plus n minus 1 into d is 2. So this is 2n plus 1. And if you see the denominators, we are having 2 comma 4 comma 6 comma so on. Till now, just now we have seen the nth term of even numbers is 2n. Okay. So next let me substitute this one. Therefore un equals to, what we get, un 1 into 3 into 5 into so on. 1 into 3 into 5 into so on. Last one for this, the nth term is 2n minus 1 divided by 2 into 4 into 6 into so on. Its nth term is 2n into x powers. This x powers are this, so this nth term is 2n plus 1 by, this is same now, 775533, so 2n plus 1 by 2n plus 1. So this is the nth term. Now we have to write un plus 1. We have to write un plus 1. So just how to write the un plus 1, see here, un plus 1 equals, you write this as it is, 135 so on, 2n minus 1. So the next term will be, in place of n you have to keep n plus 1. So in 2 into, in place of n if you keep n plus 1, what will be this one, 2n plus 2 was a 2, 2 minus 1 1 divided by, till here you write as it is, 2 4 6 so on to n. If you keep in place of n n plus 1, you multiply 2n plus 2 into x power 2 into, in place of n if you write n plus 1 plus 1, this will become 2n plus 2 ones are 2 plus 1 3, 2n plus 3. Now in the same way, in the here also it will be 2n plus 3. Now the next step is we have to use D'Alembert's ratio test. What is the formula? Limit n tends to infinity, we are using like this, un plus 1 by un plus 1 by un. So what is un plus 1? Limit n tends to infinity, I'm writing this one, 1 3 5 so on, 2n minus 1, 2n plus 1 divided by 2 4 6 so on, 2n, 2n plus 2 into x power, I'm writing like this, watch carefully, 2n plus 3, no, I'm writing plus 1. How much is left? 2 are left. 2n plus 1 plus 2, now we can write like this, into x square divided by 2n plus 3. So this is the un plus 1. 2n plus 1 plus 2. 2 will be written as x square. Now in the denominator we are having un. So what will be un? See here, this one. Reciprocal of this, 2 4 6 so on, 2n into 2n plus 1 divided by, in the denominator, 1 3 5 so on, 2n minus 1 x power 2n plus 1. Now let me cancel the terms. See here, what can the cancellations we can do, watch carefully. Here up to 2n minus 1, 2n minus 1 cancel, up to 2n, up to 2n cancel, x power 2n plus 1, x power 2n plus 1 get cancelled. Now this term is left, this term is left, x square is left, and these terms are left. So let I wrote one more time this one, limit n tends to infinity, what is left here, 2n plus 1 into 2n plus 1, we can write whole square also, divided by 2n plus 2 into 2n plus 3 into x square. So this is left here. Now let me solve, let me note this one, we have to use this maybe afterwards. Now see here, you take common and substitute the values, limit n tends to infinity. If you take common here n, it will become n square, because here we are having square, no, so actually we are taking common n square. You left with 2 plus 1 by n square divided by, if you take common n here, it will be 2 plus 2 by n, 2 plus 3 by n into x square. So you see here you can cancel n square. Here also when you have taken one n, no, this n square will get cancelled. Now if you substitute the limit, what will happen? If you substitute the limit, this will be 0. 2 plus 0, 2, 2 square 4, 4x square, 4x square by 2 2s are 4, this 2 becomes 0. So 4 4 will get cancelled, we left with x square. Therefore, according to D'Alembert's test, limit n tends to infinity, un plus 1 by un equals to x square. Since we are not getting any number constant by which we can say less than 0, greater than 0, this is variable. So we have to write all the three conditions. Therefore, what are the conditions we are having for D'Alembert's test? Therefore, for x square, what we say less than 1 implies convergent. X square equals to 1 implies divergent, and x square greater than 1 implies divergent, and x square equals to 1 implies test fails. So you see here, less than 1 convergent, greater than 1 divergent, equals to 1 test fails. So we have to find what we have to find again at test fails. So let me do one thing. We cannot go in comparison test because here we difficult to suppose. This is un by un plus 1, sorry, un plus 1 by un. We can use this here. Let me use Raabe's test. Okay, so at n equals to 1, sorry, at x equals to 1, I'm writing here, watch carefully. Here I'm writing here. You see here, at where we have to find x equals to 1 because it just failed. So if x equals to 1 here, is 1 here, what is left here? This is actually un plus 1 by un. You keep x equals to 1, so this goes, we left with 2n plus 1 whole square by, so this is actually un plus 1 by un. The value of at x equals to 1 is 2n plus 1 whole square by 2n plus 2 into 2n plus 3. At x equals to 1, this value is this. Now let me use Raabe's test. Raabe's test. What is Raabe's test? We have to find limit n tends to infinity, n into un by un plus 1 minus 1. We have to find this. So already we are having this. See here. Now let me do one thing. Equals to limit n tends to infinity, n into un by un plus 1 is the reciprocal of this. So you just reciprocal it, bring this in the numerator and the denominator. This is un plus 1 by un. We want un by, so you reciprocal this one, un plus 2 into un plus 2n plus 3 by, I'm doing one thing, I'm expanding this. A plus b whole square is a square plus 2ab, 2 2s are 4 and plus 1 minus 1. So let me take LCM here, we multiply this one. Okay, see here, equals to limit n tends to infinity, n into, if you multiply, what will happen? You see here, 2 2s are 4 into n square, 4n square, plus 2 3s are 6n plus 2 2s are 4. 6 plus 4 is 10n plus 2 3s are 6. Once more, you see here, 2 2s are 4n square, 2 3s are 6, 2 2s are 4, 10n, 2 3s are 6. Now if you take LCM, this will be multiplied with minus 1, bring this here, multiply with minus 4n square minus 4n minus 1. Now divided by, in the denominator was it left here, 4n square plus 4n plus 1. Now let me continue this one, you get cancelled. Now you see here, plus 4n square minus 4n square get cancelled. Now what is left here? Limit n tends to infinity, n into, what is left here? 10n minus 4n is 6n. 6n plus 6 minus 1 is 5. Again you see here, 10 minus 4 is 6n plus 5. Let me take n common here, so left with 6 plus 5 by n. Now in the denominator also you take n square common, left with 4 plus 4 by n plus 1 by n square. Now n into n square get cancelled. If you substitute the limit, this will 0 0. 6 by 4, 6 by 4 is nothing but 3 by 2. This is greater than 1. So in DLM burst, sorry, in Raabe's test, if we are having greater than 1, its value is convergent. So we just fail at x equals to 1, we change the method. At x equals to 1, by Raabe's test, this is greater. No, therefore at x square equals to 1, according to Raabe's test, the series is convergent. Series is convergent. Therefore we again have to write here, we have to mix this convergent and 1. Therefore for x square lesser than convergent equal to 1, also we got convergent. Therefore less or equals to 1 implies convergent, and x square greater to 1 implies divergent. So here let me do one more question. Let un equals, so you see here, this is first term, this is second term, this is third term, here 3, here 4, 1 increase by 1, no, 3 4 means increase by 1. Therefore for n you will get n plus 1 to x power 3 3. Therefore n, this is 3, this is 5, increase by 2, n plus 2. This is 3 3 6, increase by 3, n plus 3. So let this be un. No, un plus 1 means in place of n you have to write n plus 1. So if you write n plus 1 here, n plus 1 become n plus 2, x power n plus n plus 1, n plus 1 plus 1, n plus 3, n plus 4. So we have to start with, first we see D'Alembert's ratio test. D'Alembert's ratio test. We have to find limit n tends to infinity un plus 1 by un. So un plus 1 is this one, n plus, sorry, limit n tends to infinity un plus 1 is this. We have to write n plus 2. X power n plus 1 can be written as x power n into x divided by n plus 3 into n plus 4 into, if we take un in the numerator, we have to write the reciprocal of this. So let me write this. I'm writing this here. So if you write un plus 1 here, un plus 2 n plus 3 divided by n plus 1 x power n. Now you get cancel x plus 1. Now let we do one thing. Let we take n common from each factor. Limit n tends to infinity. If you take n here common, 1 plus 2 by n. If you take n common here, 1 plus 2 by n, 1 plus 2 by n. And if you take n common here, it will be 1 plus 3 by n, and x is left here, x divided by, you take n common here, 1 plus 3 by n. You take n common, 1 plus 4 by n. If you take n common, 1 plus 1 by n, 1 plus 1 by n. So let we do one thing. Let we start doing cancellations. N will get cancelled. Now if you put the values of infinity, let me substitute now. 2 by infinity is 0 0 0. So 1 into 1 into 1 is 1. 1 into 1 into 1 is 1 only, into x. So we'll get this value as x. Therefore limit x tends to, sorry, n tends to infinity un plus 1 by un equals to x. Since x is variable, we have to write all the conditions of D'Alembert's ratio test. So therefore what is here? Therefore x is, what we write, less than 1 implies convergent, x greater than 1 implies divergent, x equals to 1 implies test fails. So the test fails at x equals to 1. So let we do for x equals to 1. You see here we are having un equals to n plus 1 x power n by n plus 2 into n plus 3. At x equals to 1, what will be un? The value of un will become n plus 1 into 1 will be n plus 1, n plus 1. In the denominator, I'm multiplying this, n into n squared, 3n plus 2n, 5n plus 2 3s are 6. Now we can use here comparison test now, because its vn is easy to suppose. Let we suppose vn. The greatest term of n in the numerator is n. In the denominator, how to suppose? We have to take the greatest degree of n in the numerator and denominator. In the numerator, the greatest n is n only. In the denominator, the greatest degree is n squared. So this will be 1 by n. So this is Vn. We have to find limit n tends to infinity un by Vn. This should not be 0 nor be infinity. Then we can use comparison test. Limit n tends to infinity. What is un? Un value is n plus 1 divided by n square plus 5n plus 6. You see here, this is 1 by n. This will come in the numerator. Now you take n square common from the denominator and n from the numerator. You see here, limit n tends to infinity. If you take n common here, it will be 1 plus 1 by n. Also 1 n here. If you take n square common, this will be 1 plus 5 by n plus 6 by n square. Now this n square and square cancel. This value is 1. In comparison test, we can get any value 1 also. We can get, the test will not fail. Only for 0 and infinity test fails. So we can say now Vn equals to 1 by n power 1, 1 by n power p. So yes, what is value here? P equals to 1. So what we wrote, p greater than 1 convergent, p less or equals to 1, we wrote divergent. So therefore, what we write, by P series test, sigma Vn is divergent. Therefore, sigma un by comparison test is also divergent. Therefore, at 1 x equals to 1, we got divergence. So here, again, you have to write finally. We got divergent for 1. So again, you have to write like this. Therefore, x less than 1 convergent, x greater or equals to 1. Because for 1, we got divergent. For x greater or equals to 1, we are having divergent. You must write this step again. Okay. So we have done few questions on D'Alembert's ratio test, and it fails. Either we can use comparison test or Raabe's test. Sometimes we cannot use comparison test because Vn we cannot suppose. Then we have to go to Raabe's test. So inshallah, in the next class we are going to start the Cauchy's root equation root test inshallah in the next class.